All right, one more quick example to show you for lesson 1.9. Again, we're working on representing proportional relationships with equations. So in this one, we're talking about people on the moon. A person who weighs 100 pounds on Earth weighs 16.6 pounds on the moon. Okay, so we need to identify what is going to be our x and our y, what is going to be our dependent and independent variable. And I'm going to tell you that our independent variable needs to be the one on Earth. Okay, independent. Okay, that means to be the one on Earth because we can't really change that up, and there's not a whole bunch of people on the moon weighing something saying, hey, excuse me, I wonder what I'd weigh on Earth. So this would be dependent. Excuse me. So this is x and this is y. Okay, so I kind of answered this part already. Excuse me. I should have paid more attention to the question. But the variable that's independent is Earth, weight on Earth. And our explanation, just for the sake of time, I'm going to kind of skip. I know, shame on me. But we talked about it. You have to have your weight on Earth because we aren't on the moon to measure ourselves. So if we want to write an equation, remember, as always, we got to find our constant. So we're going to go y divided by x, and we said our y is our weight on the moon, so 16.6 divided by our weight on Earth, 100 pounds. Not 1,000 pounds, 100 pounds. I think I can write this all better. 16.6 divided by 100. So if you were to grab a calculator and do that, you would get 0.166. So that's our k. Now we can write that into our equation. Y equals 0.166 times x. But better is if we would say y. Well, y is our dependent. It's our weight on the moon, so I'm going to use m, equals 0.166 times x. X is our weight on Earth, so I'll say e. Okay, so how much would a 185-pound astronaut weigh on the moon? Well, this means E, his weight on Earth, is 185 pounds. So I can plug that into my equation. Weight on the moon equals 0.166 times weight on Earth, so times 185, and that would equal 30.71 pounds. Now, if he weighs 50 pounds on the moon, well, again, that would mean m is 50. And we're going to use our same equation of m equals 0.166e, but this time that has to be plugged in for m. So 50 equals 0.166e, trying to make it look a little different there. And as always, we're solving for e, so we have to get rid of its coefficient, 0.166, and we have to divide both of them by, 166. That cancels out to give us 1, and if you plug 50 divided by 0.166 in a calculator, you have to approximate, but it's approximately equal to 301.2 pounds on Earth. So again, in all the examples we've done, when you write your equation, you're able to fill in the information and then figure out other things based on it being proportional.